that feedback. Okay, so here we go. We did eliminating the parameter, yes?
Yes.
So we did this. Did we get all through this?
We didn't do the last one.
We didn't do this one?
You tried.
Oh, the you tried. Did you try?
Not
You just packed it up and left. Okay, you tried. Yes. Yes.
So Bill break, then we packed up the list.
Uh-huh.
Yep.
I think you had like 2 minutes left. You need to set it. All right. So yeah, they'll probably ring 2 minutes later. You just looked at your phone the last 2 minutes, but whatever.
That's not what happened.
Nope. So just so you're clear on the identity form you're shooting for, you notice tangent squared plus 1 is secant squared, right? So if you want to make a substitution of trig for a number, then you want to somehow get it to, you can have secant squared minus tangent squared, so that can be replaced by 1. Shoot, what a mess. I mean, who's to say, if you, okay, so that's a good question. Let's go back here. Did you get to the same place I did before doing any cleanup? 1 is y squared over 9 minus x over 4.
Yes.
Okay, now in terms of answering the question was eliminate the parameter. And that means get rid of t. Did I do that?
Yes.
At that point, you've answered the question. You're done. I was just in my mind thinking it said a graph. Now, I don't look at that and say, I know what the graph looks like. So I was just, after that, I was just flailing around trying to figure out how to graph it. And in an x equals y squared, it's a sideways opening parabol. I was going to try and handle it. But looking back at the question, I didn't say graph. I just said eliminate. You with me? So you didn't have to do all that stuff. That's it. I'm not done. What else do I miss? Domain and range, or one or the other. Now, this is kind of atrocious. This is why. So, so this is why you don't usually see these with tangents and secants, because it's terrible. Sines and cosines are far more common, but it is what it is. No, here's the deal. There's x, yeah?
Yes.
So what can x be? What can tangent normally be? Tangent can normally be anything, do you agree? Okay, and so because of the square, what can tangent, or 0 and up, yeah? So x is restricted to only 0 and up, yeah? All right, so only positive x's. What about y? So terrible. What is secant normally restricted to? Above 1 and below negative 1. So here, y is either greater than or equal to 3 or less than or equal to negative 3. Okay, you with me? Okay, so the point was to take two parametric equations and eliminate them. Now, your goal is to take a normal equation and bring in a parameter, or parameterize the equation. Bring in a parameter. Now, if I told you a particle moves along y equals x squared from the origin towards 3 over 9, and let's just assume it stops at that point. What are two parametric equations that could make this curve happen? Now, if you're thinking, is there an easy one in there? Yeah, there's an obvious one. What is it? Let x equal
X equals to y equals t.
Now, wouldn't that, if you eliminated the parameter, be y equals x squared?
Yeah.
Yes, it would. Okay, the most obvious is to just say, you know what, if I want to make this curve, I'm just going to let x be just the same as t, so that when t is 0, x is 0. When t is 1, x is 1. T is 2, x is 2. And it keeps going till x is 3, and then it just stops. So just let x be directly related to t. Now, if that's the case, if x and t are the same, then the only way you're going to get that same graph is if you let y equal t squared. If x is t, then y equals x squared needs to be y equals t squared. So the most obvious case, the easiest case, is just to let them straight up equal. I'm a little worried here because that's the easy one. Are we good? Okay, that's from t from where to where? 0 to 3. By going t from 0 to 3, x will go from 0 to 3, and y will go from 0 to 9. Do you agree?
Oh, yeah.
Okay, now, I don't want to lose anybody, but I also want to challenge some of those of you who are super duper geniuses. How could you get it to move the other way? What equations could you do to go it from 3, 9, 3, 3, 9,
Negative
2? So that's a good theory. That's exactly what I thought. X equals negative t. And y is?
t squared.
Y is t squared. Does that work? At 5 equals 0. Does it start at 9, 3, 9? That doesn't work. You want to start at 3 and go down. So x should be, start at 3 and go down the top. So let's try x equals 3 minus t. Okay? Now let's just check the x's. At time 3, will it be, or time 0, will it be at the starting? And at time 3, will it be at the ending? Okay, so that seems to be working x. Now let's go y. Y is, now the easiest way to do this is once you have x nailed, use it to find the y. Isn't then x, if y equals x squared, then doesn't x have to be, or y have to be 3 minus t squared? Let's make sure that works. At time 0, what's y?
Nine.
9. And at time 3, what's y? So that seems to be working. Do you agree? Yes, questions? Okay. All right. What if, instead of doing that in, this is in 3 seconds, what if I wanted you to do the original path in 4 seconds? If x is, it's still doing the same path. It's still going for the same points. The time is different. 3/4 t. Okay, let's check the times. Does that make sense? At time 0, is it at the starting point 0, 0?
Yes.
Cool. At time 3, or time 4, is that at the starting or the ending point x equal 3?
Yes.
So for x, it looks good. Now, how do I find y?
Square that.
Square that. 9/16 t squared. Let's check. At time 0, is it where it's supposed to be?
Yes.
At time 4, is it where it's supposed to be? You with me? All right. A little bit of calculus. Find slope of tangents to parametric curves. What if I gave you 2 parametric curves? I don't know what the curves look like, nor do I particularly care. I just want the slope at time equal 4. How do I do that? Y dx. Now, could I eliminate the parameter and get a yx equation and take the derivative?
Yeah.
I could. Now, the problem is that this is in terms of time. They're wanting it at a certain time. So how could I keep this in terms of t's, not x's and y's?
dy dt over dx.
Yeah, do dy dt over dx dt. What's dy dt? I think you'll agree that's dy dx. What's dy dt?
Integral of y equals t to the third minus 2, which is 3t squared
3t squared
minus 1.
minus 1. And what's dx dt? Negative t to the negative 2 minus 3e to the t. They said at 4, time equal 4, I should probably make that clear. At 4, so the numerator is 47, and the denominator is negative 1/16 minus 3 to the 4. And what that, I don't know what that curve looks like, but I don't, again, you with me?
Yes.
Now, I don't care if you do dy dx in terms of x, y, or t. I'll take either, but it really kind of depends on the question. If they're saying, hey, find dy dx at a t of 5, well, then it makes sense to stay at t. But if they say find dy dx at the point 3, 2, well, then it makes sense to go at y. Do you agree? Okay. Last but not least, don't know if we have time for this. Maybe we'll do this tomorrow. Let's go to the easier one of the two. Here. All right. So let's talk parameterizing. We made a nice, simple, along a parabola movement. Now let's talk a little more. You board a Ferris wheel at the bottom. The radius is, that's the worst circle I've ever done. No. Okay. The radius is 12 meters, and you board at the bottom. Here's you boarding the Ferris wheel with your little sweetheart. There you go. All right. You with me? It moves clockwise, so it moves this way. And it takes 20 seconds to complete a revolution. Now, all that's great. I want you to give me equations that model that movement. Can I, do you feel like do it by yourself, or you want to get a little guidance? Okay, I strongly encourage you to find these. I'll get you at least started by saying find these 4 points, time, x, and y. And in order for our equations to all be the same, I hate this when you guys say this from physics and say, depends on how you define the axis. But in this case, it really does depend on how you define the axis. So we're going to define our origin there. There's our origin. There's our point of reference. So go try and figure out equations that make that move. Math amigos.
14 for the name of the game. It was
So long as you think that you have it.
I have
You have it. Yeah, it helps a lot. Some of you can just see it, but it helps a lot if you think of how x changes with time. At time 0, x is 0. At time, what's a quarter of the time? 7. At time 7, x is what? Negative 12. So time-wise, at time 7, x is negative 12 when it started at 0. Does that help?
I walk along the diamond. Wait, Mr. Rickman, do you actually walk along the diamond?
We'll probably do it tomorrow. I don't think I have time. In fact, I know we don't have time. Okay? So with that said, x is what amplitude?
12.
12. What kind of curve? Positive sign, negative sign, positive
Negative sign.
negative sign. What's the coefficient of t if the period is 28? What's the period? What's the coefficient? 2 pi over 28 or pi over 14t. Verify. At time equals 0. What do you get?
0.
At time equals 7. What do you get? Sine of negative, or sine of pi over 2 is 1 times negative 12 is negative 12. Okay, it's working. So try the y, get the y before it's too late. Think of what the y's are each time.
I can't call Mr. He probably is a tree. Compared to all our grades.
Yep. This? Oh, this? Yep. Coefficient is 2 pi over the period. Okay, so y is?
Hey, look, the bell rang.
I was looking at my phone.
Pi t over 14 minus 12? Or plus 12?
No, it's plus. Oh, I'm so close.
Sorry, it's a 12 vertical shift and it's a negative cosine wave. Yeah? That's it.
Or you can make a negative sign and plus 24. Oh, no. You know, I guess figure came up. Oh, maybe. Oh, maybe. Oh, maybe.
You could, if you're looking at shit.
Let's just say my output grade is going down to a delta.
I'm ready to go.
Have a lovely day.
I have an